When dealing with the installation of non-UL listed equipment, especially in situations where local inspectors require UL listing, several options can be considered. Firstly, contact the manufacturer of the non-UL listed equipment to inquire about obtaining UL listing for the specific equipment model. This process may involve testing and certification. Alternatively, hire an independent testing laboratory to evaluate the equipment and issue a UL listing or certification. Secondly, you can request an exception from the local authority. To do this, approach the local authorities and provide documentation or evidence to support the safety and reliability of the non-UL listed equipment. Emphasize the lack of comparable UL listed equipment for this specific application. Offer to take additional safety measures such as enhanced fire protection or monitoring systems. Thirdly, explore alternative listings or certifications. Research other safety standards that are accepted by the local authorities, such as nationally recognized testing laboratory listings. Obtain certification from a reputable agency such as the Canadian Standards Association that meets the equivalent safety requirements of UL. Fourthly, propose performance testing. Offer to perform an independent performance testing to demonstrate the safety and functionality of the non-UL listed equipment. Engage a qualified electrical engineer or testing laboratory to conduct rigorous tests that meet the intended application requirements. In addition to these options, there are several additional considerations to keep in mind. Ensure that the electrical installation is fully compliant with all applicable electrical codes and standards regardless of the equipment listing status. Consult with an experienced electrician and electrical engineer to ensure proper grounding, overcurrent protection, and other electrical safety measures. Document the process and justification for using non-UL listed equipment in the facility's electrical documentation. The specific requirements and procedures may vary depending on the local jurisdiction and the nature of the equipment. It is recommended to engage with the local authorities and industry professionals to navigate this process effectively. When installing electrical equipment, adherence to the National Electrical Code, or NEC, is crucial. The NEC provides comprehensive guidelines for safe electrical installations, covering aspects from wiring methods to overcurrent protection. Several articles within the NEC are particularly relevant to ensuring safety when installing electrical equipment regardless of its UL listing status. Article 110 covers requirements for electrical installations, including examination, installation, and general use of equipment. It emphasizes the importance of equipment being suitable for the specific installation and environment. Article 210 pertains to branch circuits, detailing requirements for circuit sizing, overcurrent protection, and permissible loads. Proper branch circuit design is essential for preventing overloads and ensuring safe operation of equipment. Article 220 covers calculations for branch circuit, feeder, and service loads. Accurate load calculations are necessary to determine the appropriate size of conductors and overcurrent protection devices. Article 230 addresses services, including service entrance conductors, overcurrent protection, and grounding requirements. A properly installed service ensures a reliable and safe connection to the electrical supply. Article 250 outlines grounding and bonding requirements, which are critical for minimizing electrical shock hazards and ensuring proper operation of overcurrent protection devices. Effective grounding and bonding create a low impedance path for fault currents, facilitating the rapid clearing of faults. Article 300 provides general requirements for wiring methods and materials. It covers aspects such as conductor protection, support, and installation practices. Selecting appropriate wiring methods and materials is essential for maintaining the integrity and safety of electrical circuits. Article 310 focuses on conductors for general wiring, including conductor ampacity, insulation types, and installation requirements. Proper conductor selection ensures that conductors can safely carry the intended current without overheating. Article 400 covers flexible cords and cables, detailing their permissible uses, limitations, and installation requirements. Flexible cords and cables must be used in accordance with their listing and limitations to prevent hazards. Article 408 pertains to switchboards and panel boards, including their construction, installation, and overcurrent protection requirements. Switchboards and panel boards serve as distribution points for electrical circuits and must be properly designed and installed. Article 430 addresses motors, motor circuits, and controllers, covering aspects such as motor protection, overload protection, and control circuit wiring. Motors require specific protection and control measures to ensure safe and reliable operation. Article 440 focuses on air conditioning and refrigeration equipment, including disconnecting means, overcurrent protection, and motor compressor requirements. Air conditioning and refrigeration equipment have unique electrical requirements that must be addressed. Article 445 pertains to generators, including their installation, overcurrent protection, and grounding requirements. Generators provide backup or supplemental power and must be installed in accordance with safety standards. Article 450 covers transformers, including their installation, overcurrent protection, and grounding requirements. Transformers are used to step up or step down voltage levels and must be protected against overloads and faults. Article 480 addresses storage batteries, including their installation, ventilation, and charging requirements. Storage batteries are used in various applications, such as emergency power systems, and require specific safety measures. Article 500 through 516 provide requirements for hazardous locations, including areas where flammable gases, vapors, or dust may be present. Electrical equipment used in hazardous locations must be specifically designed and approved for those environments. Article 600 covers electric signs and outline lighting, including their installation, wiring, and overcurrent protection requirements. Electric signs and outline lighting require specific safety measures to prevent electrical hazards. Article 620 pertains to elevators, dumbwaiters, escalators, moving walks, and similar equipment, covering their electrical wiring, control circuits, and safety devices. Elevators and similar equipment have complex electrical systems that must be installed and maintained in accordance with safety standards. Article 640 addresses audio signal processing, amplification, and reproduction equipment, including their wiring, grounding, and overcurrent protection requirements. Audio equipment must be installed in accordance with safety standards to prevent electrical hazards and ensure proper operation. Article 645 covers information technology equipment, including computer rooms, data processing systems, and associated equipment. Information technology equipment requires specific wiring and grounding configurations to ensure reliable operation and prevent electrical noise. Article 680 pertains to swimming pools, fountains, and similar installations, covering their wiring, bonding, and grounding requirements. Swimming pools and fountains pose unique electrical hazards and must be installed in accordance with stringent safety standards. Article 690 addresses solar photovoltaic systems, including their installation, wiring, and overcurrent protection requirements. Solar photovoltaic systems generate electricity from sunlight and must be installed in accordance with safety standards to prevent electrical hazards. Article 695 covers fire pumps, including their power supply, wiring, and control circuits. Fire pumps are critical for fire suppression and must be installed to ensure reliable operation during emergencies. It is important to note that this list is not exhaustive, and other articles within the NEC may also be relevant depending on the specific equipment and installation. Consulting the latest edition of the NEC and engaging with qualified electrical professionals are essential for ensuring compliance and safety. When dealing with non-UL listed equipment, several key electrical safety measures should be implemented to mitigate potential risks. Firstly, ensure proper grounding by connecting all non-current carrying metal parts of the equipment to a grounding electrode system. This helps to minimize electrical shock hazards and provides a path for fault currents to flow back to the source, tripping overcurrent protection devices. Secondly, utilize appropriate overcurrent protection devices, such as circuit breakers and fuses, to protect the equipment and wiring from overloads and short circuits. Select overcurrent protection devices with ratings that are appropriate for the equipment and the circuit. Thirdly, implement surge protection to protect sensitive electronic components from voltage transients and surges. Surge protective devices, or SPDs, can help to divert surge currents away from the equipment, preventing damage. Fourthly, use proper wiring methods and materials that are suitable for the equipment and the environment. Ensure that conductors are properly sized and insulated and that wiring is installed in accordance with applicable electrical codes. Fifthly, provide adequate ventilation to prevent overheating of the equipment. Overheating can lead to insulation breakdown and other electrical hazards. Sixthly, conduct regular inspections and maintenance to identify and address any potential safety issues. This includes checking for loose connections, damaged wiring, and other signs of wear and tear. Seventhly, provide clear and visible labeling to identify the equipment and its electrical characteristics. This helps to ensure that personnel are aware of the potential hazards and can take appropriate precautions. Eighthly, implement lockout-tagout procedures to prevent accidental energization of the equipment during maintenance and repair. Lockout-tagout procedures involve disconnecting the equipment from its power source and applying locks and tags to prevent it from being turned on. Ninthly, provide training to personnel who will be working on or around the equipment. Training should cover electrical safety procedures, hazard recognition, and emergency response. Tenthly, conduct regular electrical testing to verify the integrity of the equipment and the electrical system. Testing may include insulation resistance testing, ground impedance testing, and continuity testing. Ensuring compliance with applicable electrical codes and standards is essential for maintaining electrical safety. This includes the National Electrical Code, as well as any local or regional electrical codes. Consulting with qualified electrical professionals, such as licensed electricians and electrical engineers, can help to ensure that electrical installations are safe and compliant. Additional safety measures include using ground fault circuit interrupters, or GFCIs, in wet or damp locations to protect against electrical shock hazards. GFCIs are designed to detect small ground faults and quickly disconnect power to the circuit. Also consider using arc fault circuit interrupters, RFCIs, to protect against arc faults, which can cause fires. RFCIs are designed to detect arc faults and quickly disconnect power to the circuit. Moreover, implement regular housekeeping practices to keep electrical equipment and wiring clean and free of debris. Dust, dirt, and other contaminants can contribute to overheating and electrical hazards. Furthermore, ensure that electrical equipment is properly rated for the voltage and current requirements of the application. Using equipment that is not properly rated can lead to overheating, insulation breakdown, and other electrical hazards. Lastly, provide adequate clearance around electrical equipment to allow for safe access and maintenance. Clearance requirements are specified in the National Electrical Code and other electrical codes. These measures, when implemented correctly, can significantly reduce the risk of electrical hazards associated with non-UL listed equipment.